For posterity, anybody judging Tyler, he did do an excellent bio that you have not heard.
All right, let's get this all set up. Awesome. Okay.
To the rest of the internet, Tyler's just some dude.
Awesome. So just as we talked about before, we'll talk about some typical networking patterns that we see in these different cloud environments, whether it's on-prem or at the edge, and talk about how people have been successful deploying Kubernetes and OpenShift clusters there, and deploying applications and consuming those in these various environments. Let's get into that. So it's interesting when you get into these different environments, especially the on-premise and at the edge locations, where sometimes you do not have, like in a typical cloud provider, APIs that will automatically provision a load balancer up for you, right? So automatically provision a load balancer, configure the routing to your backend VMs or Kubernetes services or things like that, and then forward that traffic. You actually just have infrastructure, and that's all that environments provide, right? So you have infrastructure, you have a switch, a router, and that's pretty much what you have. And in these environments, there's creative ways that people will go about exposing their applications, either just within that data center, or if there is some network infrastructure to provide a path to expose that to the public internet, exposing that to the public internet if they're trying to offer their services on the internet. Typically, by default, what people will do, and we'll show an example here in a bit, is you can actually have a service if you have no load balancer services, and you can configure the networking to basically have the node's IPs, right? That default route that node's on. And when traffic comes in on that node IP for one of its interfaces, it can actually send back either on port 3 or port 80, typically is what we see, to a load balance, or to a Ingress controller. Pick your favorite one, whether it be Nginx Ingress in the community, or OpenShift has the OpenShift router, which is an HA proxy based Ingress controller, and will handle, once you get your traffic into that front end Ingress controller, then you're all within the cluster network, right? You can do a lot of cool things as far as SSL termination, the load balancing to multiple different backend services, SSL configuration, all those various things, right? So now it's awesome, and I'll just take silence if that's making sense, and definitely feel free to jump in, and I think it'll probably relate a little bit more to when we actually look at the technology itself. Now, one thing to note is sometimes, right, when you use the node's infrastructure, like the node IPs directly to route that traffic in, obviously nodes can be dynamic in some of these cluster environments. Nodes die, new ones come in, get replaced. Typically, clients will have systems, and a lot of these platforms, including ours, will dynamically update DNS records as those change. But sometimes clients consuming those applications are sensitive to IP-based changes, even if it's behind a DNS record. So what you'll see, and there's actually solutions out there. One of the favorite ones is MetalLB, that will allow the provisioning of load balancers and really a static IP that can move across nodes that you can use to expose services that's managed in a highly available way. Basically, you have members that sort of talk to each other and are like, hey, this node's going to hold on to this IP at this given period of time. And if that goes down, the other, people know to, or the other processes know to take over that IP address. And even as nodes come in and out of the cluster, you still have a stable IP that you can always access your services over. And typically clients like that, when they're trying to firewall things in their network that they're consuming applications over, they can have that set IP address versus having to have, sort of a range that dynamically changes as, infrastructure comes and goes. So yeah, that's awesome there. And then on the flip side, right? So that's typically involving clients consuming applications that are like, running in, let's say, an on-premise or, customer or, at an edge location. Now, flipping it around, when you enter into a lot of these different environments, you will enter into a lot of different networking configurations and security requirements depending on the client that you deal with or the environment that you're trying to network into. And there's a couple of popular patterns that we've seen as far as really, I'll call it centralizing the point that all egress traffic, as far as a OpenShift or Kubernetes cluster goes, centralizing where all egress traffic leaves that data center and providing hook points to where a security team could deploy, a proxy, let's say, like whether it's an HTTP proxy or, there's a lot of solutions out there like Broadcom, Bluecoat, different things there, to where they will have all outbound traffic go through that hook point and be able to monitor and look at traffic flows and, just different streams going through and make sure that everything looks and is acceptable. And then if not, have that point to cut off communications at a will, right? Just by doing that configuration in one place and blocking any abnormal communications that that they don't want. What we typically see clients do is in these environments, they will actually use like, an HTTP proxy both at the node level. So if you really break down a Kubernetes cluster, there's almost like two different layers of networking, I'll call it. You almost have networking at a node level, right? A host level, which is sort of, you'll see your container runtimes there, whether it's like containerd, CRIO, your different runtimes that you can plug in. Kubelet operates at that host network level. And then actually the SDN plugins that you deploy, whether it's Calico or Cilium or whatever, they're actually operating at the host network level and laying down everything that's building up that software-defined network level. And then when you're actually running applications, right, whether it be like, your favorite web UI or, portable database or whatever it might be, that actually runs at the software-defined network level where you have your own dedicated, DNS servers, whether it be core DNS or whatever is utilized in your environment. You have that SDN plugin building that software-defined overlay across these nodes and making sure that the pods, even though they're referring to just their pod IPs, once you actually look into the details of how everything goes down and networks traffic, and this side sort of shows it, right? You'll actually have your software-defined network plugins build out various underlays, right? Whether it's like VXLAN tunnels across the nodes. Sometimes they use IP and IP encapsulation. Sometimes they have eBPF that's hooked into the routing layers to do that sort of encapsulation. But really, make it so handle all the dirty work where the pods can just use those pod IPs, and then it will handle getting that across the core network backbone of the data center. So what you need to do, that was a long way of saying, what you need to do if you really want that hook point as far as integration goes, is you need to have proxy integration not only at the host network level, but you also have it at the software-defined network level as well. And in a lot of these environments, clients will have configure, typical like HTTP proxies and TCP proxies that will basically take all those well-known endpoints, and you can think about it as like, obviously the kubelets are communicating to like the Kube API server. There's some other, maybe components on the control plane side that are being interacted with. And all that traffic gets forwarded through the proxy. And of course, if these components are reaching out to any popular public services, like, if for whatever reason they're reaching out to Google.com, or there's a public API that they rely on that they're reaching out to, they'll be configured to go through that proxy, and everything can be monitored, and then sent back out. And that single point of egress of data center traffic is there. Awesome. And then continuing on, in some client environments, how would I describe this? Basically, you will, where it might, so basically previously what we talked about is really looking at how to do networking within the core infrastructure of the cluster itself that's running these services. And then if you look on the flip side where clients are consuming those again, sometimes the clients consuming it aren't like on, I'll call it like how we are today, right? Where we have a laptop connected to the internet. We have full access right through our ISP, no sort of firewalls, points of entry to, monitor that traffic and things like that. Some client environments, when you get into, really locked down industries, all their users, when they actually log on to their laptop, instead of just, going directly to the internet across like the ISP, they'll actually be set to talk to an HTTP proxy in their network, and they'll want to access all services through that, including like, kube control. If you have web-based UI applications within your environment, they'll want to access those, right? So whether it's like, a console, like, the Kubernetes dashboard is a good example, or the OpenShift console is another one that's popular. They will route all traffic first to a proxy, and then that proxy will actually handle doing the DNS resolution within that, private network, and then forwarding that traffic ultimately to whether it's kube control traffic, which is going to the control plane of these clusters, or if it's actual like, containerized applications, and this is your, Kubernetes dashboard, maybe your favorite database UI or a database API, things like that, all sort of your containerized applications. It will forward that traffic to that environment, go back to the proxy, and then go out to the client, to where instead of the client having to build network routes to all these different components that might be in different networking spaces, they just have to build the connection and ensure they have a connection to this proxy. And then the proxy handles, having connectivity to all the services that are going to be exposed through them. And again, that typical sort of nature as well with security teams that can monitor any client traffic that's coming in and make sure clients are doing any abnormal activities, and if so, shut those down in a single place. So that's definitely another popular pattern that we will actually, I'll touch on this. This is pretty OpenShift specific, and I'm not sure if any of your companies actually use OpenShift in that environment. But what we have seen in the industry is there's a lot of these clients that are on their cloud modernization journey don't come in day one and have everything containerized, right? It's just not, it's not the way that things, that things are currently with a lot of these clients, right? They will have a large fleet of VM-based applications, and then they'll have some applications that are containerized, and they'll have a strategy on, I'll call it key stakeholders and key applications that they're really interested in containerizing in a iterative process to gain a lot of the benefits through containerization, right? Some of the, especially when you combine it with a container orchestrator, a lot of the HA benefits, the failure domains, the high redundancy, scalability, all those sort of good things. But what you'll see in those environments is they want to have their VM-based applications seamlessly interact with their containerized applications, which gives them a pure strategy to where, okay, I now feel comfortable taking just one VM application, containerizing it, because now I can seamlessly talk back if I rely on like these 4 applications to support that one application, right? If these 4 are my dependencies, I can containerize this and still seamlessly communicate in my containerized software-defined network to my VM-based application. What you'll see in the community, OpenShift virtualization is based off of KubeVirt, so that's like the open source version. And that allows clients to actually run VM-based workload in the same software-defined networking layer as containerized workload. And they can seamlessly communicate across those and dynamically provision those. And now you really have a powerful story on the modernization journey. So just wanted to touch on that, as that's another popular one that we definitely see with clients sort of earlier in their cloud modernization process as far as that goes. And moving on. With a lot of the regulation that's going on in the industry today, as far as, with data residency and really this push to keep all infrastructure, what I will call it, in a local geo, right? Whether that be, with EU, right? Keeping all the infrastructure, with EU law, all within the EU, and there's different, variations across that. Or, with the security conscious clients where they really want to make sure that their data is staying within their data center and not leaving, right? So what we've seen a popular mode as well. And then another piece to touch on, especially when you move out to these telco edge environments and running clusters out there, you actually might have a long distance between your control plane, right, and where your worker node is that's running the actual applications, right? So your control plane that's sort of, scheduling these applications and controlling that, and the actual, VM that is VM or bare metal that is running those workloads at the edge. And specifically in those environments, it's actually pretty typical to see networks get cut off between the control plane and that downstream node. And the idea is, what you don't want to have happen there, and what Kubernetes is great with, is you want everything when that network connectivity happens, as far as your data plane goes, which is your application running at that edge, to continue functioning, right? You might not be able to do some of the management capabilities associated with it, like deploy a new version or do an update. But as far as your pure data plane and clients consuming whatever that, edge application is, or that, disconnected, that application that's running in that disconnected environment is, you want that to stay up. And that's a popular mode that that we see where, clients will have this disconnect, have this disconnection for, let's say, even multiple days at a time, right? They will keep their workload will keep running. And then when they want to, let's say, do, some of the management operations, right? Deploy a new application, upgrade a node, things of that nature. They'll actually restore that connection and, do their management functionality, and then cut that connection again. And really what that sort of gives them, some comfort in when they actually cut that connection is they have full control and know, right, there's literally no egress out to, the internet on for my data to go over, right? So now I can rest assured that all my data is, staying within this environment and things of that nature. So, and obviously with the telco use case, right, when networks go under maintenance and things get cut off, you don't want that to all of a sudden get into a state where when that's restored, it's, it requires a lot of operations to bring that online. So those are some of the two typical cases in that environment. And I think with that sort of would close the presentation of things. And then, we'll put some of these cute, fluffy little words that we've been talking about here and show some of the technology and look at, some of these networking patterns live if y'all are interested in that. So I'll pause and see if anyone has any questions. If not, we'll just keep on moving on.
I don't know if you're going to touch on this, Tyler, but on the border gateway protocol and all that stuff, where does that kind of fit in when you're talking about these cross cloud, cross internet type connections? Where's the BGP fit into this? Does it fit anywhere or where?
Yeah. So it's a great point. So let me sort of get into that piece there with exposing these applications. So a lot of times with BGP, where that sort of fits in is in environments that support it, when you actually can add BGP on that layer, picture you have, I'll call it 5 different redundant deployments. You take example, and I showed one data center here. Now picture you duplicate that deployment across 5 unique data centers that all sort of have, an equal cost path to each of those redundant services. You can actually add in BGP and advertise those, I'll call it, those static IPs that we talked about, to have equal paths into each of those data centers. And then you can really start to highly scale out how your clients are connecting across and going into those redundant deployments of those applications. And that, we see those really in those, I'll call them advanced deployments, because typically when you start getting into multi-data center BGP, that takes some pretty hefty networking experts. But with those advanced deployments where we're really trying to gain a lot of throughput from a client perspective on what we're able to serve them, you'll see that sort of get added in. Does that make sense there?
Yep. And so maybe you're going to go into this too, but when you talk about global load balancers, like Google has the best, I think. What are they using in that regard to actually go across in a global way the actual networking between the areas? What are they?
Black magic.
Anycast.
Just Anycast, yeah, BGP.
Or is it just Anycast that they're doing? Okay.
So you could do the same thing with BGP. If you have an ASN,
Right.
you could announce the same IP in 5 locations. And
Yep. Okay. So, but they're using. Okay. So this one. Okay. We have sorry if you wanted to know.
And I'll be honest, that's typically some, that typically are some more advanced configurations. You can think one simple one that we see a lot of clients implement is picture you have 5 redundant data centers, but you don't have that all set up. Picture you just have it to where you have, a DNS service, whether it's Akamai or whatever, and you put health checks, right? Like these DNS service can health check your services, and you'll put, let's say, 6 different IPs, right? If it's 6 different data centers in your back end, that's one IP into each data center, and it will just run health checks, and it will take out from that DNS record, if a data center goes down, if those health checks will fail, it'll take that out from being served to clients, and then it will also handle as clients make DNS requests, right? Okay, this 30% I'm going to serve it data center 1's IP. These 30% I'm going to serve it data center 2 IP, and things like that, right? Because that's sort of a more simple solution that's pretty portable across a lot of these core data center environments. Does that make sense?
Yeah. And maybe one other one. I don't mean to capitalize, but when you're talking about geo sticking, right? You want traffic to go to a particular geo. What's kind of the methodology that's being used for that?
The easiest way is you do Anycast for your DNS, but then you return Unicast. So you can get the information off of DNS, and then you pin them by explicitly routing them to a place.
All right, thank you. right,
Yeah,
thanks.
look, I should probably just sign off now, right? Y'all already know all the answers, so I'll just sign off now and go home. But no, excellent. No, it's an excellent point. That's exactly.
I am curious, so what you mentioned, like, the telco edge, that kind of stuff, what does a small footprint of this look like? I saw DNS servers in some and data centers in others, and like, if you boil this down, what's like a minimum layout look like?
Yeah, so a popular one that we see the most of is a lot of these edge networks, like these telco edges, they're going to be connected back to, I'm going to call it a hub. And that's where like your AI, like, your models and like a lot of these compute will go on. So at the edge, and if you break down a Kubernetes cluster, right, you will see literally one node. And it will be like one, like picture in a cell tower, like one little box there. And all your control plane components, which was where a lot of like the, heavy lifting and CPU and things like that are coming from, will actually be running in that hub, and it will connect across that that line from that hub to that edge location. And where your applications are running, it will be that small of a footprint. So whether it's like a 4-core, 16 gig box, right? That's sort of what you can like look at going on in that environment. Does that make sense overall?
Yep, thanks.
Thank you.
Awesome. Very cool. So we'll jump in, and then of course, if anyone has any questions, we can definitely circle back to this. So what I just wanted to do, instead of just sit here and show like slides, because that will get boring, is actually look at some live environments and sort of show typical nature of how those services go. So let's actually look at one and show an example. So, sorry, go on.
Could you increase the font size, please?
Yes. Let me know when that is good.
Just like one character per screen? No.
Is that big enough, or is that still too small for y'all?
Okay.
I can go one more.
You just want to wrap.
I can see it.
There we go, that's good.
Darkin's an old man.
I am.
Thank you.
No problem at all. So, and what we'll focus on really is, how people are exposing these applications in this environment. So, in this cluster that I have, and let me see if I still have the log in here. I can show an example. So, let me get my nodes here. And basically what we have now is, this is an IBM Cloud Satellite OpenShift cluster that's deployed in a private VPC in a on-prem data center. And in this environment, what I talked about, where this is like a bare bones environment, right? So it has no like integration for dynamic load balancers. Basically, you literally just have the boxes that you can bring up. They have IPs, and then there's a base networking layer that gets you sort of a private VPC, or that gets you sort of like your private connectivity across those nodes. And then there's access through that. There's a path of access through that through a VPN that you can actually get access into that VPC as well from the outside world. So I actually have that fired up now. You can see the nodes that I have here, and specifically the IPs of them, right? So that 10.240.0.19 and 10.240.0.20, just IPs of those nodes within that data center. And what we'll look at here, and I talked about, right, is picture you have a web-based application that you're trying to expose in this cluster, and this is the only networking infrastructure that you have. So you have those nodes IPs. It's built a software-defined overlay, right, based off of our SDN that's been deployed there, which in this environment will be Calico, and and so what we'll do is show how we can access a web application here, which is going to be the OpenShift console. And first, I will just go to that, and then we'll get into the details of how that all occurred. So let me just type in that. here. And we'll see that I get directed there into this environment. In my web browser, I got like a nice like UI that shows me, you know, I can view all my workload, all my pods that are running across all my different projects, and things like that, right? The specifics of the web UI doesn't really matter, I guess, in this point, but just you know, the network into that is what we'll jump into that. So we can actually look, and these are the actual pods that are running, that are serving this web page. And if we break it down further, we're going to see that there's a service that points to those pods. And then if we go further from there, what we're going to see as I resolve this domain is, let's look at that. We're going to see that points to that 240.0.19 and that 240.0.20 address, which obviously, right, relates right back to the node IPs that we have. So we have a load balancer, right, that points to those infrastructure IPs directly. And then when I access that over my VPN, I'm able to directly connect in and get to that service. Now, there is a layer to touch on as well. So we touched on the backend service, but what we didn't touch on is the Ingress controller and load balancer that's running within the cluster that's handling fronting, you know, traffic coming in on this IP on port 443 to ultimately this backend application that's serving the console. So we can see that as well if we look at the service in the OpenShift Egress. You're going to see that we actually have these router pods and this service that points to these router pods. That you'll see that there's IPs hooked into that say, hey, when traffic comes in on 10.240.0.19 or 10.240.0.20 with port 80 or port 443, please forward that to this to these pods here. And if we look at this, then what we'll see is if we actually were to, you know, jump into this and look at the config. Gets off. And we're going to cat HA proxy, this HA proxy config here. You're going to actually see that there's all these backends that will point to the actual backend pod IPs based off the domain that comes in. So you'll see like where are some of the domains. I won't hit on all of them, but I'll touch on one just to make sure that you know, this was called that. Is let's see where it is. So it would be like console, OpenShift, console. Fingers crossed. It's in there somewhere, but you just gotta sometimes read all these configs to find where that is. You can definitely see the back. Yeah, opens the console, downloads. Now the question is, where does it put that front end? Back in there. Header host. So I think those connections are yeah, so it's sort of a little, and where is this?
It is.
OSSNI path. Yeah, there we go. So there's those domains. So you'll actually see some of those domains in that console OpenShift Tyler and how those sort of get redirected and then fed into this H8 box configuration. So some of the specifics, now that's all sort of abstracted away through, obviously, and you'll see that with, if you use Kubernetes clusters, right? You can either have routes or ingresses as well, right, for your typical OpenShift or your typical Kubernetes. But sometimes it's cool to see how all this high-level config actually gets translated into a working deployment. So what you basically saw there was, again, from those node IPs into on port 80 and 443, those will forward back to these pods, and then when you looked at that config, it will ultimately map back to the console here. And then from there, you get a full path in this bare bones networking environment to ultimately expose, like a web app or whatever you'd be interested in. To go to the next, or sorry, did someone have something?
You had MetalLB as well. Is that something that would sit in front of this, or this? Because this is just a host port pod listening on the right IP and then a DNS pointed at your nodes, right?
Exactly right. Exactly right. So where MetalLB fits in, and that's exactly where I was going to go next. So now, if we looked at that piece, and let me try to give an actual live example of that. So now picture I am a client trying to consume this service, and I am very strict on my security standards, and I can only allow one IP out of my firewall, right? As I add nodes in and out of this cluster, how I access that service is going to change, right? Because it's using the node IPs directly. So let's say I actually, these nodes, I decommissioned them. I added in new nodes that are 21 and 22. And I was an existing client that firewalled 19 and 20. I'm now broken, right? Like now when I try to access a service, it's not going to allow me through my firewall. It will fail. Where MetalLB comes in these environments, sometimes there are actual floating IPs, is what I will call them, which are IPs that their network will route into the subnet or VLAN, but actually aren't assigned to any machine. So they're free to float around, and it's on the onus of components running on these machines to either do like the layer 2 ARP, like the gratuitous ARP, and make sure that that IP actually maps to a machine. And what they'll do is you can have a floating IP that's managed across, 2 machines, right? So it'll be assigned to one machine, and these components like communicate with each other, just like, are you alive? Yep, I'm alive, and I'm like the leader. Oh, you're not alive anymore. I'm taking over this IP, and send that gratuitous ARP out. And what you'll get is you'll get a static IP if you have that, if you configure MetalLB. Now that I don't necessarily have in this environment, but what you'll see is there'll be additional 2 things that will go on. There'll be additional pods in a namespace that will run that protocol. So I'm not sure if y'all are familiar with VRRP, for example, and KeepAliveD, where pretty much you'll have like a KeepAliveD process running that they're communicating to each other, over multicasts, as we talked about, and basically electing a leader, and then it gratuitous ARPing. You'll have that same system with MetalLB, and you'll configure this service to where now it's like just a cluster IP. It will actually turn out to be a load balancer IP, and your external IP will be just that floating IP. And as you add in nodes in and out, it won't matter. You'll still have that same IP that you're consuming, and your clients won't have to react if they're in these firewalled off environments to infrastructure changes. Does that make sense?
Yep.
Yeah. And I think those are, I think we're at like the hour here. Those are some of the interesting ones. And you can sort of build off from here. So one thing that's of interest here, if you look, And this is really, I think it's an interesting point to point out. In a lot of Kubernetes clusters, you actually will see the master nodes, right? So you'll see, like, they'll be in the same cluster, there will be, your control plane nodes that are running like your master components and worker nodes that run your applications. There's different flavors of, Kubernetes and OpenShift where those are actually isolated and they're in separate networks, and if you'll notice here, you'll actually only see and ignore like this master piece sort of makes it confusing, but that's not like actually a master node. So you can actually look at, like, if you look at the pods in this cluster, you'll see nothing called like a Kube API server or things like that running in this environment. When you split out those control planes I mentioned, that's where we start to get into what I talked about, those remote edge environments, right? Where if you have this edge environment where you are really resource constrained at a telco edge, but you have that connected to a hub, and you can put your control plane in that hub that's not resource constrained and run that highly available control plane, multiple instances, for redundancy, all that good stuff. And then you just connect a remote worker node across that's really small at your edge. That's how you can start to build out these edge topologies where if you tried to stuff that all into like a cell tower, you'd fail because it doesn't have the resource, like there'd be no resources to run the actual application because basically everything's getting consumed trying to run the control plane on it. So I just think that's something to touch on, before I close out here, as something to note in some of these distributions where you'll see that actually get isolated, and actually the control plane components, since they're fully managed by like a service like ours, won't even be shown to the clients. Like they'll just see like their worker nodes. They can add and remove as pleased. They can obviously run kube control commands against the managed control plane, but you won't actually see like the nodes and things like that, and that's fully managed and extracted. So I think with that, that's pretty much all that I wanted to cover, and hopefully that was helpful for everyone and insightful.
Any questions? So I have one, sorry. On the cube edge, where you're actually doing like IoT, like you're talking about, in the sense that you're having very low powered type devices and or your connectivity is not guaranteed. Connectivity as well as your bandwidth is not guaranteed. This is what you're saying, that you'll actually have the control plane outside of that minimal environment. Be aware of the disconnected way of working, and then when it reconnects, then life is good. So is that correct?
That's correct. The only asterisk I will add, with life is good, life is always good with your live application at the edge. Right. Where life in that disconnected mode gets like a little impacted, I'll call it, is just your management operations, right? So picture when you schedule a new deployment to the API server and you need to roll out like an update, that would obviously be impacted because you need to communicate back to the API server, and that node will have to talk back. But as far as your core live application, you're all good. It can run disconnected for, a long period of time. Does that make sense?
Yeah, but the question I have then was, is there ever like a kind of a hybrid, in the sense that in that disconnected world, you're not going to have like the ability to do like HPA or other things, because the actual schedule controller, all that stuff is still on your control plane. So you're basically just having an embedded thing out there running, and you hope it just stays up, although it can restart. That's fine.
Yeah,
Exactly. Exactly. You're thinking about it exactly right, though. You're right. Some of those more dynamic pieces, you're absolutely right, are impacted in that mode. But you're you can restart. You can have some of those modes in there where that stays alive through, a certain subset of things. Does that make sense?
Yeah.
I think I've seen some people that even will use static pods, so like actual manifest on the
Yeah.
on the node.
On the node itself.
Just because if it's an app that they want to ensure doesn't require the control plane, you can still have it run. It just isn't as nice. Like having deployments that modify static pods on nodes is a little weird until you realize that like it is hyper constrained, and sometimes they actually can't even roll out a deployment without taking it offline. Like it's expected that it's a restaurant that shuts down at 2 a.m.
Yeah.
They have a maintenance period, and so they don't even need an HPA or something that could like scale the like pod disruption budget. Doesn't matter because it's a closer to like a static deployment
Yep.
than
Interesting.
Kubernetes dynamic.
That's exactly right. And picture if you're talking about telco towers, like they'll have multiple towers, right? So they'll take a tower down for maintenance, and it's not that they're looking to scale in that tower. They're looking to have 50 different towers, right? And okay, we'll take this one down, and now I got like my 49 other that are servicing the area, right? So that's exactly a great way of looking at it, if that makes sense.
Yeah, I remember this is a few years back. I think it was the first or second KubeCon where the example was a cable TV. Remember that one?
Yeah, totally.
And they went to Kubernetes as a solution for their administration, their operational, and they used it in such a kind of an interesting disconnected world, but they were using it basically the whole Kubernetes structure just to facilitate the operational administration. It was a lot easier because the disconnected node, approach and all that stuff. But I thought it was very interesting that still, I guess you see more and more people doing that, or is it just?
It's a way to replace. So like they probably had a custom control plane or
Yeah, they must have had something
there.
Yeah.
And so if you go all in on Kubernetes and this can help you solve that problem, it's tolerable. The more interesting one is KubeVirt, where it's like, oh, you want to run some VMs somewhere.
Yeah.
Run them in pods, and it's like really weird to think of that. But if it actually it adds complexity to the pod, but removes complexity from the
On the other side. Yeah.
that you can just ship. You fix it in software instead of hardware, which is.
So how does that? Sorry, getting a little more on. I like the edge stuff a little bit, but as far as the networking of that, where you're having, let's say, very low bandwidth. No, we don't go into the bods anymore, but I mean, we're talking about.
In IoT, we do.
I know in IoT we do, but I mean, let's say we're not guaranteed a very, very large pipe at all, as well as it's coming up and down. Is there special mechanisms on both sides to take care of that, or do you
Pre-cache your images
Yes.
and update them overnight.
is that basically what's happening? So you'll keep a little bit of extra storage or whatever that means, either, and then okay, all right,
You can also do some generative stuff, like basically like patching, but for the whole OS. So you don't ship the difference.
Diff images. So I do know people that don't rebuild from scratch. They rebuild on top, and then that way, if the diff layer is really small, that's easy to ship overnight. And in fact, it's a tar file you get out to the node and deploy things that way.
You typically also have kind of emergency backcatches, is like, oh, we're gonna have to ship someone out there with like a hard drive that they just shove in the thing and press a button, or whatever the case may be.
Yeah.
And those have to be built in before you start, because after the fact, they're impossible.
Yeah, back in the day, which I wouldn't have known, but that's when they'd use the streaming tape device for that initial boot, right?
Mm-hmm.
That would be, All right, thank you. All right, any other questions or thoughts or?
I missed the beginning, sorry. Did you talk about Multis at all and anything with multiple CNIs? I saw that running in your test cluster. I'm just curious, like, what are some of the use cases and, I don't know, or is this something you're just playing with?
Did you hear Blake?
Or sorry, no, go on. Did someone have something? All right, I can go.
Sorry, can you just repeat it? Just repeat it. He can hear you.
You're using Multis for KubeVirt, right?
Yeah, so I actually did not touch on Multis at all. I sort of glossed over that, but you're exactly right. Couple of things that we see Multis used and is really popular for. One, SRIOV operator, right? So building your SRIOV networks. on top of Multis, right? And that integration with some of the, oh my gosh, what am I blanking here? You know, some of like the capabilities for those nodes, especially in those telco environments for those performance sensitive, latency sensitive applications. That's a popular one. Kubernetes another. But I did not touch on that in this presentation, but it's definitely used. What I showed, right, and especially satellite, it's based on OpenShift, right? So OpenShift heavily uses Multis, like, you know, it's a stock in every OpenShift deployment that's out there. So there's definitely a lot of use cases for that. I'd say those are the two popular ones, if that makes sense. Does that make sense?
Yeah. Any other? All right, Tyler. Thank you very much. Appreciate you.
Thanks y'all so much for all your time. You asked excellent questions, and y'all were like a great, like, thanks for hosting me. I'm so grateful for all y'all's time. I hope y'all have a wonderful night, and talk to y'all soon. So just thanks again.
Thank you, Tyler. Take care.
See ya.